Well, hello, geometers and seekers of general truths. Let us look at a couple of theorems here regarding tangents of a circle. Okay, in a plane, a line is tangent to a circle if and only if the line is perpendicular to a radius of the circle at its endpoint on the circle. Okay, so let's call this the circle tangent theorem. Okay, let's give it that name here, at least for our purposes here. And let's see, let's start out with a circle. Okay. That's not a great looking circle, but we have a line that's tangent to that circle. So let's say this is line M, and let's say there's a radius here called Q. A center here called Q, and you have this picture. So you have line M, a point P, and then a center Q. So this statement says that M is tangent to circle Q if and only if the line is perpendicular to a radius of the circle at its endpoint on the circle. So if and only if QP, that's the radius, is perpendicular to line M. Okay, so in other words, this is true. This line M is tangent to the circle if and only if that angle right there is 90 degrees. Okay? We will prove this later. The proof to this is a little bit challenging, but and also very, very beautiful, but we will prove it later. Okay? So for now, the main takeaway is for you to understand what the theorem says, what the conditions are. You have a line that looks like it touches the circle. That line is tangent to the circle if and only if it is perpendicular to one of the radii at that point. All right, let us continue then. Next theorem that says tangent segment from a common external endpoint, so common and external here, are congruent. So we'll call this the tangent segments theorem. We'll call it this tangent segments theorem. And let's look at a picture as well. So let's see. So let's get a picture of a circle. And this is saying tangent segments from a common external endpoint. So let's say I have some endpoint here, and then I draw this line. Oh, let me try to draw this a little bit better than that. Okay, so let's say I have this picture here, and then I draw this line. Okay? And this is where the line is tangent to the circle. And then I draw another line here. You can give me a picture here. And that's also tangent to the circle. Okay? So what that means, let's name this here A, B, C. Okay? So if, let me rephrase it another way. If AB is tangent to the circle, if A and AC is tangent to the circle, okay, so if AB is tangent to the circle and AC is also tangent to the circle, then those two line segments must be equal to each other. So then AB must be congruent to AC. And this theorem we are actually going to prove. And we're going to prove it by just adding some additional information here. So let's say that this circle has a center named Q. And we're going to try to prove that these two blue line segments here have to be equal to each other. So, and the proof is relatively short. So we're going to add a few statements. And we'll do the proof on this side here. Okay, so proof. Number one, BA or AB must be perpendicular to QB. So QB here is the radius. This must be true. Well, why? Well, the theorem we just talked about in the previous theorem right here, the circle tangent theorem. So this is the circle tangent theorem. And number two, you could also say then that QC must be perpendicular to AC. So AC is perpendicular to QC by the exact same reason. Let me try this better. Okay, so we're almost done now, believe it or not. And then we can make a couple more statements. QB and QC are congruent. Because they are both radii of the same circle. And notice here that if I take a line segment and I draw it from Q to A, I've basically broken up this this picture up into two separate triangles. And you see that I have two right triangles with the same hypotenuse. So we can also say that QA is congruent to AQ by the reflexive property. And then you can see here that you have two right triangles with the same hypotenuse and one identical leg. So therefore, the other leg, AB and AC, must be equal to each other as well. And I'll let you fill in this reason here. All right, why is this true? There's a special theorem that we've used a lot that explains why this is true. Okay? But in this case, that completes the proof of the question. Okay? And it's actually the Pythagorean theorem that states this is true. So if you have a hypotenuse that's the same and the legs that's the same, then the other leg must also be the same. Alright, so we'll end this video here. We've covered two theorems here that involve tangents. And then in the next video, we'll look at some example problems. As always, thank you for watching and have a